Hello, this is Mr. Taylor with Young Engineers Today. We're going to continue with ancient engineering with a focus in architecture. Parthenon. Located in Athens on the hilltop of the Acropolis, which translates to high city roughly. It was a temple for the Greek goddess Athena, who's the goddess of wisdom and military victory, as well as the patron of Athens. It was constructed between 447 and 432 BC and took only 8 or 9 years. Made up of two back-to-back halls, as you can see here. Now, the columns that these two rooms, as a review, we have Doric columns were simple and stocky. Ionic used for smaller buildings and interiors. There's also Corinthian, developed by Greeks, but actually used more by Romans. This Doric here, Ionic on the inside. Parthenon's foundation made of limestones. Columns are made of marble. Before the Doric marble, temples were constructed made of wood in the Doric style. Athenians wanted a more durable temple. Their wealth and large population of citizens and slaves made all the stone Parthenon possible. It used a post and lintel style, which does not use any mortar. Here are some more examples of this. Parthenon used over 20,000 tons of marble. And Greeks used a variety of simple machines you can read below to make this possible. The tools that quarrymen and stonemasons used were made of iron and wood, as you can see in the images. Now, this process that the stonemasons and quarrymen would do is use a fissure, which is a crack along a natural crack in the marble, and use it with simple machines to split it and move it out of this location. Then they would start chiseling and shaping the capital, but not finishing it. They would finish on the job site because in case anything would happen to it during shipping. Next, they would have to hoist it out. These capitals would usually weigh around 26,000 pounds. And they would use ropes, pulleys, and winches, and animals and raw muscle to help move these out. Then they'd put it on a wagon for shipment. Then, after the 11-mile day-long journey, they would use a pulley system with brakes and mules to help pull it up the hill to the top of the Acropolis to put it in location. Then once it was at the top of the work site, it would join a dozen other partially finished blocks. But here they would remain for 4 decades for the midst of the construction of this temple. The old Parthenon, the Persian attack Athens and destroys the partially built structure. So they got started with it, but then wasn't finished for 50 years later. On the same site, 430 BC, after 8 years of construction, the Parthenon is nearly complete. 1,000 marble blocks intended for the first temple have contributed to the second, even grander one, is the first Greek temple built entirely from marble and a testament to the skill of the men who worked the stone. Now, a few optical illusions going on here. The purple lines look like they're bowing because of the light rays around it. As you can read here, the Athenians knew that building a perfect temple would appear imperfect based on a similar effect. So this is what they did. They actually made the columns have a swelling outward appearance. It didn't affect the overall structure, but actually affected your optical vision of it. Once again, they did this with the horizontal line, built convex to correct sagging. So it's curved, and so it looks straight. Same with the vertical lines. They were inclined inwards to correct appearance of falling outwards. So they took something that was perfect, but because our eyes will trick us, they made some changes to it. So as a student once referenced, like, you made something imperfect to make it perfect. And that's one way of saying it, but the fact is it's still structurally sound. Throughout history, the Parthenon originally was a temple. It has acted as a church, a mosque, and even a munitions depot during the Turkish occupation of Greece. In 1687, during a battle with the Venetians, the explosion caused most of the damage seen today. If you use the link below, this allows you to design your own Greek temple. Try that out, please. This is a Greek temple in Minecraft. Pretty cool stuff there. You can actually look that up on YouTube, and it shows you how to actually build it. Now, Roman advances. Roman roads, arches, Roman Colosseum, aqueducts. Why are roads important? Roads are important for many reasons. They allow for quick, easy travel, help economy by allowing commerce between cities and towns, strengthen empire by allowing the military Roman legions to move quickly. Here's the design. I want you to notice that the road is actually arched on top for proper drainage into your drainage canals. And look at the amount of layers and time and thought and process that went into building one of these roads. They were designed to last. Here's an image of a road in Europe that still exists today from Roman times. Some of the challenges: expensive work. It was very time intensive. Natural obstacles had to be overcome. Did not use compass or maps. So, how did they manage to build a straight road without a compass or map? Let's look at this. They use a tool called a gromma. A gromma is an instrument with a square cross composed of two pieces of wood nailed together, right angles in all corners. Each piece of wood had lead weights attached at the ends. A straight line was confirmed when one lead weight lined up with one in the front of it on the same piece of wood. Once the surveyor was sure that the straight line wooden posts were dug into the ground, Roman soldiers did most of the building. It's almost like surveying. The Romans built 40 kilometers of road throughout Europe, into the Middle East, past Turkey, and throughout northern Africa. And the network roads in ancient Roman world were very impressive. 29 of the highways led to Rome, and this is using the phrase, all roads lead to Rome. All right. Leads us now to the arch. Arches add stability, strength, beauty into the Roman structures. Their functionality came from compression, forces being pushed outward into the support structures, and the load on top. Arches work due to having weight on top of them. The Colosseum is basically made up of multiple arches to give it strength. It's a large outdoor stadium. As you can see, the specs here. It's a massive structure. Held around 50,000 people. It was used for gladiator games, mock battles, dramas, etc. Excuse me. And here's some more information about it. Okay. Now, once again, the aqueduct being built up of arches. Excuse me. Romans built aqueducts to bring water into Rome. And also the arch was used in a very similar fashion for roads. Bridges. Why did they need to bring water in? Not enough water from the city's original water source, the Tiber River, to meet Rome's demands. Rome supplied water to private homes, wealthy, those peasants who could afford the charge, and also the plethora of public baths, fountains, and public toilets. They built 11 aqueducts in total between 312 BC and 26 AD. And they would fill the inside of the aqueduct with gravel, sand, and stone to create the weight to go around the arches. Now, aqueducts work by dugout channels underground and create networks of pipes to carry water from outer source into Rome. Pipes were typically concrete, sometimes lead. Siphons were used to create enough momentum when the pipes had to span a valley. Here's a comparison between aqueducts then, aqueducts today. Very similar, so we keep all of our piping underground now, and we have a treatment plant. Here is a Aqueduct Minecraft video. I recommend looking this up on YouTube. shows you how to build an aqueduct in Minecraft. Alright, that's the end of that. We're going to switch over to SketchUp. Alright, what we're going to do here is focus on downloading SketchUp for next class. Alright, go to SketchUp.com. You're going to download SketchUp. Now, it's important that you choose the educational use version and not the Pro version. The Pro 2015 version you will have to pay for. The educational use SketchUp Make is free. Now, you'll fill in the boxes. Excuse me. You'll select student. Put your email, your name. If you are at a homeschool location, just put Young Engineers of Today or put whatever school you attend. Public, private, parochial, whatever. Then select your computer type, Mac or Windows, and then SketchUp Make, okay? Then hit download. Here's an overview of that again. All right. Once you download that, some basics we go over next class are selection tool, drawing lines, drawing simple figures, pulling, pushing, planning and orbiting, rotating, moving, and zooming. All right. You will, once you have it open, go ahead and experiment with it. Choose a template. When you choose template, choose simple template, feet and inches. It'll give you a better idea of what you're working with, unless you have really mastered meters with the metric system. All right. Once you go in, you'll have your opening screen, as you can see here, and then you have your instructor. Make sure you have your instructor on board, and it's in one of your top drag down menus. The main reason we want to have the instructor, he gives us tips and tricks on how to do different things and gives us insight that is very useful for learning how to use SketchUp. All right. Also, we want to have the tool palette out where you want the large tool set, and it will be off to the left. And this has all the tools necessary. All right. We will stop here. Go ahead and do some experimenting with SketchUp. If you have any problems, please email or check us out on Edmodo. We can help you out with loading SketchUp. Thank you. Take care.